let's put in here. Step number 1. Use the Pythagorean trigonometric identity, right? So I'm just I'm shortening it like such. Pythagorean trigonometric identity. And what will that be, guys? Sine squared t plus cosine squared t is equal to 1 squared. You good? Right? Got it. So let's use this formula for such. So what's your sine t? Negative 1/4. We're gonna square that one, by the way, right? So that's what? Negative 1/4. We square it plus cosine squared t is equal to, well, 1 squared is basically just 1 itself, right? And let's continue, right? So what's that? What's square of negative 1/4? Anyone? 160. Very good, Candle. So this one, since that's negative, even if it's negative, if you square it, it's still going to be positive anyways, right? So 1 squared is 1, 4 squared is 60. Plus cosine squared t is equal to 1. Again, our goal in here is to what? Step number 2, to solve for the trig value, right? The remaining trig value. In this case, that remaining trig value is cosine, right? So how do we solve for what in here? Cosine of t, right? So, in short, we're gonna isolate that cosine t, right? How do you get rid of the 1/16? Minus or subtraction, right? Very good. Let's put that one in here like such. Minus 1/16. There we go. Canceling it. Hence, you got cosine squared t is equal to, you can use your calculators for such, right? Do not approximate, right? Get the exact value in fraction form. If it needs to be simplified, you can use decimals to simplify it quickly. What you got? 15/16. Thank you. Well, you just want cosine of t. How do you get rid of that square? Square root both sides, right? By inverses, you square root both sides. So in here, what I'm gonna do is this one, right? Since this is a fraction, I'm gonna split the square root between them two, right? So I'm gonna square root the numerator 15 and also the same for the denominator 16, right? So I'm gonna split the square roots on both. So with that being said, this will cancel out by inverse, square and square roots being inverse. Hence, cosine of t is simply what? Well, square root of 15, we cannot simplify it. However, 16 is a perfect square of what?
4.
4, right? So square root of 16 is basically 4. Okay. Now, step number 3 in here. Okay. Simplify the fraction form, right? So when you say simplify the fraction form, the denominator cannot have a square root, alright? So if it has a square root, what you're gonna do? Well, multiply both sides in such a way that you get rid of the square root on the denominator, right? So review on your simplifying radicals simplifying technique. We good? Okay. So that's step number 3. Simplify. If it's in fraction form, definitely. If it's integer, if it has no fraction, then there's no need to further simplify it. Are we good? Right? Next one, step number 4. Right, so let's read that one in here. Paula, let's read that one. Step number 4.
What is its sign, positive or negative, based on the quadrant?
Right, so that's quadrant 3. So if it's in quadrant 3, we know, okay, again in quadrant 3, we know that it's what? The x and the y are what?
Negative.
Both negative. Very good, right? So that means the cosine, which is the x coordinate, and the sine, which is the y coordinate, are both negative. So in that case, your cosine t in here should be what? I'm going to put in here negative square root of 15 all over 4. Are we good? Guys? By the way, in here, yeah, that will be it for now for this one, right? So again, to review the steps that we did for this one, if you are given sine, the angles quadrant is given. To get the other trigonometric function, use Pythagorean trigonometric identity. You're going to use some algebraic techniques in here, like what? Squaring a number, isolating a term by subtraction, and inverse or removing square by square root both sides. Step number 2, solve for the trig value, as we said regarding those. Simplify. If it's in fraction form, simplify in such a way that the denominator should not have a radical sign anymore, right? If not, what do? Multiply both up and down by the square root of whatever the denominator is, right? Bless you. Next one, sine. Is it plus or minus? Depending on the quadrant. In here, it just so happens it's the third quadrant. Hence, both sine and cosines are minuses. Are we good? Let's read this one. Number 55. Okay, let's read that one in there. Anyone? Logan.
5 quadrants of the point on a circle with a radius of 20 corresponding to an angle of 120 degrees.
Thank you. All right. So what we're gonna do in here? Well, let's visualize it first, right? Where is this? 120 degrees, right? So we got some straight edging here. Let that be your x and your y. Okay. Let's draw a circle. In this case, the circle is not a unit circle. It's a circle with radius 20 units, right? So let's create in here a circle with radius 20 units, okay? So just this high-tech compass, right? High-tech. And technologically advanced compass, right? There we go. And do this one in here. Just to make some, convincing circle. Looks convincing, right? Enough, right? Okay. Now, where is that 120 degrees? Well, let's use our protractor as well, right? So, where is that? So, if I put this on the center, make sure that that is 0. Good, right? Okay. And then, see where it is. So that is 0 looking below, 10, 20, that's 90, that's 120 degrees in here. Okay. So I'm gonna have that point, and once again, use this to at least have some, as much as we can, some convincing angle measures in there. Yeah, there you go. So again, that is how much? 120 degrees. Okay. Once again, guys, the radius in here is how much? 20 units instead. So again, in here, it's not a unit circle anymore. The radius is 20 degrees. Right? You good? Okay. Now, what do? Coordinates, right? So what are the coordinates of that 120 degrees? What's the first thing that we're gonna do? Get the what? Reference angle. Right? So let's get the reference angle for this. Step 1, what's the angle reference? Well, actually, to get the angle reference, step number 1, okay, here it is. Okay. Well, first of all, make sure that the angle is in standard form. Meaning it's less than 2 pi or less than 360 degrees, positive. So check, it is, right? Step number 2, what's that again? Quadrant location, right? What is its quadrant? 2. There we go. Okay. Step number 3. Well, what's the angle or reference angle formula in quadrant 2? the reference angle formula in quadrant 2, guys? Should we subtract it 2 pi or 180 degrees, or should we subtract it from 180 degrees? From 180 degrees, right there. So that's 180 degrees minus 120. What did we get?
60 degrees.
60 degrees, right? Get it? Okay, so verify our sine and cosine for that 60 degrees. So let's visualize first. Where is that 60 degrees, by the way, right? So here's what I'm gonna do. I'm gonna draw this along the x-axis because again, reference angle is defined as what? As an acute angle in here, right? Okay. An acute angle with respect to the x-axis. The nearest x-axis in here is a negative, right? So that's how much? 60 degrees, right? And with that, by special right triangles, what are the values here? Well, this is, how much is this again? This is 1. How much is this?
Half.
1/2. Very good, right? The shortest leg of a 30, 60, 90 triangle is always half the longest leg, right? Or hypotenuse, right? And this one is always going to be what? Square root of 3 over 2.
If the radius is 20, then why is the hypotenuse 1?
Yeah, so that's what we're going to do later, right? So as we know, on the unit circle, that is 1, that is 1/2, and that is square root of 3 over 2, right? But that's a good analysis there. Since our radius is 20, then what we're going to do with all of them? Multiply all of them by 20 as the radius, right? So again, this special right triangle, the 1, 1/2, and square root of 3 over 2 only works for a unit circle, right? But since in here, the radius is 20, then what we're going to do? Multiply everything by that radius, right? So let's put that one on the steps in here, right? Step number 4, right? Use special right triangle, okay? Or Pythagorean theorem, right? To solve for what? Sine and cosine, in this case. Okay, and then after that, what do we do then? Step 5, consider the sign, right? Sign, is it positive or negative? Again, that depends on the quadrant. Are we good? So in here, since this is in quadrant 2, let me choose a different color. Let's choose a blue one. Right? Oh, I got a blue one. There we go. So let this blue one be what? This point is where now? What is the x value? Among these two, which one is the x value? The 1/2 or the square root of 3 over 2? 1/2, right? That's always the cosine. And this is always going to be the square root of 3 over 2. That's the sine, right? It's always 1. In terms of sine, quadrant 2 is what? The x is negative, the y is positive, right? So that means this is what? Negative 1/2, and this is what? Positive square root of 3 over 2. Again, that's only for a unit circle, right? But again, since the radius is 20, I'm going to add in here step number 6. Okay? Right? Multiply the coordinates by what? Whatever your radius is. Okay, guys. So in short, what's the answer in here now? The final answer for P is how much? Again, multiply this everything by 20 as your radius, okay? So what's 20 times negative 1/2? Negative 10, very good. And what's this in here? Well, 20 divided by 2. 20 divided by 2. 10 times square root of 3, right? So this is what? 10 squared of. Are we good? Get it, guys? Thank you. Any questions?